Hi guys. Hi guys, welcome back to the vlogs. That's disgusting.
Okay, 7-4. We're going to talk about similar right triangles. Continuing 7-4 with similar right triangles. Okay,
How many slides are in this one?
I think just 4. Okay, what is WY? That's what they want us to find. What is WY? Let's see if we can figure this out with using some, talking it out and figuring some things. We want to know what WY is. Okay. WY is this length right here. Okay. This is 13, that's 12, and the other side is 5. So I have 13, 12, and 5. This is 13, this is 12, this is 5. What do you think we could do to figure out what WY is? Any suggestions, any ideas?
Could you figure out the base of XW, or the line of XW, because it's 2/3?
Why do you think XW is 2/3?
It looks like it. I don't know.
Well, you might be onto something. Let's see something. This angle here, this shows that this is an angle like this, and this shows that this is a right angle. So that is what type of bisector?
Perpendicular.
When I bisect from a vertex to the other side, creating a perpendicular bisector, which means what? What do we know about perpendicular bisectors? You gotta go back to orthocenters and
It
things.
splits it into
It's what? Is that what goes with perpendicular bisector? I'm asking you? Okay, so what do you know about circumcenters? So when
It's
you,
equidistant from each vertex of the triangle.
it's equidistant from each vertex of the triangle. Okay, so here's the deal. If I have this triangle going on, okay, I have several triangles happening here, correct? Okay, several triangles. This angle here is listed as a right angle. This angle here is listed as a right angle. Okay, so now we got to start visualizing the triangles and shaping them into the way that they look so that I can correspond parts together. Okay, if this is a right triangle right here, I have triangle VWY, correct? I'm going to redraw it because I'm telling you right now, I can't visualize these things without redrawing them. So I'm going to redraw it and I'm going to say VWY. And I'm marking that right angle so that I know that that's what's happening. I'm explaining why as we do this. So I don't know what VW is, okay? I don't know what VY is, but I do know that I don't know what WY is, but I do know that VY is 12, okay? I'm going to then copy this larger triangle, this big one here. You see that big one? And I'm going to set it up straight as well so that I can take a look at this. Now, my right angle on this one is at Y, so it's VY. VYX. Okay? VY is 12. Yes? YX is 5. And I know that VX is 13. Okay? Do you see how I flipped those around so I can see some stuff? You're probably going to have to redraw things. Okay? So I have this information now. I see that VY corresponds with VX. Do you see that? Okay, they're corresponding sides. That VY on the small triangle corresponds with the hypotenuse of VX on the large triangle. Okay? So I have 12 over 13. What am I trying to find? I'm trying to find what? WY. WY is here. This is what you're trying to find, yes? What, Priya? I do set up a proportion. So, I'm just gonna give this the term of C because there's X's and Y's going on, so I'm trying to come up with a different one. So, how would I set up a proportion for that? 12 over 13, okay, equals C over 5. Beautiful. Cross multiply, what's 5 times 12?
16.
And then I get 13C, right? Divide by 13, what does C equal? What?
It says 4.615.
Beautiful, 4.6. And that's how I can solve this. Do you see how I have to separate the triangles first? I'm telling you, if you don't separate the triangles first, most of you will fail. Yes. Most of you will not succeed if you don't separate them first. I've only met a few people that can do it in their head and not have to separate them. So find the angles that they give you that are the same and turn your triangles so that they're facing the same way. Does that make sense? And label them and go from there. If you don't, you'll probably end up confusing yourself. Okay? You need to redraw them. If you want to draw them in different colors, some people don't redraw them and they highlight the triangles in different colors. Do that too, whatever works for you. But I'm telling you, you can't just look at it. I already know. Okay. The converse of the Pythagorean theorem. So Pythagorean theorem tells me if I have a squared plus b squared, I get c squared, right? Well, it tells me if I have a right triangle, then I can use that formula. The converse says if the sides of the triangle have lengths a, b, and c that satisfy a squared plus b squared equals c squared, then the triangle is a right triangle. So normally they tell us it's a right triangle, we use Pythagorean theorem. Now they're telling me check to see if a squared plus b squared equals c squared. If so, hey, you've got a right triangle. Okay? So it's just the opposite. Nothing new there. You do that all the time. You've done it prior to seeing this converse, okay? When we checked to see if three side lengths would equal triangles, we did it that way, remember? Okay? You totally got that. Piece of cake. Okay. A triangle has the sides 2, 3, and radical 13. Is it a right triangle? Okay. How do we prove if something's a right triangle? Pythagorean theorem. What does your c squared always have to be? The longest side. So is 2, 3, or radical 13 your longest side? I don't know. Check. Make sure. No. Your calculator's set up wrong then. Radical 13 should come out to a decimal of something.
3.66.
3.6? Okay. 3.6. So radical 13 in this case would be the largest side. So I have to put that as my c squared, right? That's my c squared. So I'm going to say radical 13 squared equals 2 squared plus 3 squared. 2 squared is 4, 3 squared is 9. What is the square root of what happens when I square a radical? Just cancels the radical. So, does 13 equal 13?
Yes.
So, is it a right triangle? Yes.
Oh, goodness.
Okay, so it is a right triangle. Does that make sense?
Yes.
Mm-hmm. Because when I square a radical, it gets rid of it. Okay. Classifying triangles using Pythagorean theorem. If the square of the triangle's longest side is less than the sum of the squares of the other two sides, then the triangle is acute. So if c squared is less than a squared plus b squared, the triangles are acute. For some reason, I only have 4 slides and I should have one more, so I'm gonna make my own in a second. Okay, so if c squared is less than a squared plus b squared, you have an acute triangle. Okay, so that's how I tell, if I can tell it's a right triangle, because right equals a squared plus b squared equals c squared, yeah? Acute equals a squared, well, here, this way, equals c squared is less than a squared plus b squared. What do you think obtuse is going to be then? Yes, c squared is greater than a squared plus b squared. That's the slide I forgot to put on, and then we'll do a practice problem. Okay, so right triangle, when you're checking it, when you're checking to classify the triangle, you're gonna say, oh, it's right because a squared plus b squared equals c squared. You're gonna say, oh, it's acute because c squared is less than a squared plus b squared. Or you're gonna say, oh, it's obtuse because c squared is greater than a squared plus b squared. It's kind of common sense, okay? I think that's common sense. You can figure that out. Same formula, you just try it different ways, and you're like, oh, I know what type of triangle. So they're gonna give you problems tonight where they say 3, 7, and 12. Okay, create a triangle. Tell me what type of triangle it is. Is it right, acute, or obtuse? And you're gonna always say the largest one is always your C. So you would say 12 squared, and then you would say equals 3 squared plus 7 squared. If that comes out, if 12 squared is larger than those, then it's obtuse. If 12 squared is less than those, then it's acute. If 12 squared happens to equal those, then it's a right triangle. Does that make sense? Okay. And then, let's see here. So an example of that would be this. Let's say you have a ship whose sail, whose mast, okay, goes 56 feet high, 68 feet, and 33 feet. Okay, so I have the ship, its sail is like that. Okay, according to the measurements given in the diagram, is the mast perpendicular to the deck? So is that mast a right triangle? How do I figure that out? Okay, so what's my c squared?
68.
So 68 squared equals 33 squared plus 56 squared. Tell me what those numbers come out to be. You guys are lazy.
68 squared equals 4,624.
4,624.
Oh, I don't like that. 33 squared equals 1,089.
1,089. 3,136. So add 3,136 and 1,089 together. 4,225.
That's not a right triangle.
So is that a right triangle?
No.
So the answer would be no in that case. Then it says, the pirates think that they have fixed their ship. The line is now only 65 feet in length instead of 68, and it hits the deck 33 feet from the mast. It is now only 55 feet from the deck up to where the line connects. Have they fixed the problem? So they said, okay, we changed this to 55 feet, and we changed the hypotenuse to 65, is that what I said? Yep. 65, have we fixed the problem? Well, let's see. 65 squared plus 33 squared plus 55 squared equals what? 33 squared is 1089. What's 55 and 50, or what's 55 squared?
65 squared is 4,225.
4,200 and what? 25. What's 50?
3,025.
3,000 and what?
25.
25. So I have 4,225 equals what?
4,115.
4,114. So, no, they still didn't fix the problem. So neither of those are right triangles. Can you handle doing that tonight? Okay,
Yes.
that's what we're looking at. So, Caleb?
Come on, Bryson. You're gonna be right person today.
Braces in it.
Like, subscribe, comment, tweet me at David Dobrik. Anything else to add, Bryson?